made it to the last lesson in your construction unit of area and perimeter. Congratulations, just a couple more minutes to go and one more shape to tackle that we haven't tackled yet, and that is a trapezoid or trapezoids, because trapezoids actually come in different shapes and sizes. So in the last video, you probably heard me say the words parallel sides like 4 times, but it wasn't right. I was supposed to be saying diagonal sides. Well, that's where I got it from. Right before I did that video, I was thinking too much about trapezoids, apparently. So the formula for the calculation of a trapezoid is area equals the sum of the parallel sides, and the parallel sides are the sides that run alongside each other going horizontally. Or if the shape is tilted this way, they're going vertically. But it's the sides that are sort of going towards the angles. So a trapezoid comes in many different looks. It can either have a point on either end, or it can lean to the left, or it can lean to the right. Parallel lines, so I wanted to include a little definition for you. Parallel lines are lines that run in the same direction as each other. So perpendicular lines are going to be lines that cross, like we saw in our diagonal lines practice in our last lesson about rhombus and kite shapes. So our formula looks like the sum of the 2 parallel sides, so this length plus this length, and then what you'll do is you'll multiply it by its height, and then you'll divide it by 2. Now, if this was a composite shape, like we've been doing before, you could have calculated the area of the square and then the area of the triangle. But now there's a formula that helps us calculate the entire shape without having to calculate 2 areas, and makes it a lot easier on. All right, so the first trapezoid we have here, my friends, is a right-leaning trapezoid. That means that it angles to the right. And we need to calculate its entire area because we have the word area here. So the first thing I'm going to do is I'm going to write in my formula. Now I can use the letter P like I wanted to be doing for the last lesson. So now I know that it's going to be parallel length, which is one of these, plus parallel length. Now you'll notice that in our last shapes, our kite shapes, we use the multiplication. You'll have to be able to remember that for a trapezoid, it's addition, and for kites and rhombus, it's going to be multiplication. Now what we're going to do is we're going to multiply it by the height, and then another step, we're going to have to divide it by 2. This ends up being our longest formula for any shape. So now we can plug in our values now that we have the formula at the top. So my first parallel length is 20 kilometers. My second parallel length is 50 kilometers. My height is 19 kilometers. And now I got to divide this all by 2 and get my result. So when you plug this particular calculation into your calculator, you can do it in bits and pieces, or my friends, you can do it using the brackets that are provided for you in the calculator. They are found right there above the delete button. And so you can plug it in like this, but because of bed mass getting in your way, you do not want to add the division symbol yet. So you're going to want to do your 20 plus 50 in brackets multiplied by 19, and then you'll hit your equal sign, and then you'll get your results. I have my 0 decimal set really high right now, and now is when you'll want to hit the divide, and it'll say answer divided, and then I can put my 2 divided by 2, and then I'm going to get my answer of 665 kilometers squared. And that's the answer to our first trapezoid. How am I supposed to calculate the area of a trapezoid when it doesn't have any dimensions? I don't know. All right, let's give it some dimensions. So our second trapezoid has a left and a right lean, so that means that it goes out leaning on both sides with an angle that's different than a 90-degree angle. And we have our dimensions. So I'm going to put in my formula first, as always, just to keep myself organized, and that is going to be parallel length plus parallel length multiplied by the height of the shape, and then divide that all by 2. So I have 2 parallel lengths. My first parallel length is 1.5, and I'm going to add that with my second parallel length, which is 3. Include my brackets there. I'm going to multiply it by its height, which is 2 meters, and then I'm going to divide that all by 2. Again, I'm going to show you our calculator input. We are going to want to avoid putting the division in yet because it will mess up our calculation. So we get our answer, we got 9, and now we can divide it by 2, which we will get 4.5. Another way you could check your answer to make sure that you're calculating it right is by dividing this into composite shapes and then calculating your triangles on either side and calculating your square in the middle if you were unsure if you were completing the questions right. So there are a couple trickier questions that you are going to come into contact with in this particular notebook, and this is one of them. It's going to try to mess you up a little bit. This question says use the trapezoid method to calculate this composite shape. So in the past, when we had seen a shape with 2 triangles and a square, we would have been calculating the area of 1, 2, and 3 shapes. But the trapezoid method allows us to simplify that process by using only one formula instead of having to calculate 3 separate shapes and calculating 3 formulas. So the only difference here is that we have to add up our missing values and figure them out so that we can get 2 parallel lengths and a height. We have 1 parallel length at 5 centimeters. We have our height at 3.5 meters. Remember, sometimes it's written on the inside here, and then sometimes it's going to be written like this, depending on the question. So we have our first parallel length, we have our height. The one thing we are missing is another parallel length on the bottom here, so we have to figure it out. We can use our lines here to sort of figure it out. So we know that this is worth 1 meter, and so then this side with the same line is going to be worth 1 meter. The only piece that we're missing is this center piece, and it is giving us a symbol, so we should probably look around our shape to see if there's another symbol like that. As it turns out, there is, and it is worth 5 meters. And now I know that my entire parallel line down here is 1 plus 5 plus 1, which equals 7. So my second parallel length is 7 meters. We are totally ready to put in our formula. So area is going to equal parallel length plus parallel length multiplied by the height divided by 2. So my first parallel length was 5. We have to add that with 7. We have to multiply it by the height, which we have at 3.5, and we have to divide it by 2 and get our results. And our results end up being 21 meters squared. Ladies and gentlemen, once again, if you missed any of that or something is not making sense to you, you need to stop, rewind, check the video again, and make sure that you are understanding things. If the idea of composite shapes is not making sense to you, I would suggest rewinding, going back to our lesson on composite shapes, both area and perimeter, reviewing it, reviewing your questions, and reviewing your notes so you can gain a deeper understanding. Once again, congratulations on finishing yet another unit in grade 7 and 8 math, and you will be getting a review in the coming week.